Okay, logarithm. Okay, logarithm. If a and n is a positive real number and n is equals to a to the power of x, then log n base a is equals to x, where a is not equals to 1. Okay, so we can change the index form to the logarithm form. Okay, so how we express this logarithm form is just, if in index form, that is, we have n is equals to a to the power of x. So in logarithm, okay, how we can understand this is, what we can say is that a must power what to become n. So a must power x. Like here we have a power x equals to n. So a power what equals to n. So a power x. Alright, for example, let's say so if the base is 10, okay, that's mean log base 10, this is what we call an common logarithm. And basically for common logarithm, we didn't write the 10 there, so that's mean if this is just log x, so that's mean that is log base 10, or the common logarithm. And if the base is e, okay, which is log base e, okay, this is what we call a natural logarithm, and we have a special expression for that, which is ln n. Okay, so we change log base e to ln, or ln. Okay, ln n. Okay, so this is two special logarithm, because these two types of logarithm is exist in our calculator. All right. Okay, so note that if a and n is a positive integer where a is not equals to 1, alright, so log base 10n is log n. So this is what I told before. Okay, if log base 10, okay, basically we didn't write the base 10 because this is already don't know that this is known as a common logarithm. If there are no base here, that's mean by default that is base 10. Right, so log base 10 is 1, or in general, if we have log a base a, that is just 1. Okay, if we have the same radicand and the base, that is 1. Okay, so a log base a1, okay, if any base and the radicand is 1, that is equals to 0. Okay, because a to the power of 0 is equals to 1. Alright, and this is what I told before, log a base a is just 1. Okay, the fourth thing that we must know is that if a to the power of log base a, okay, the key here is the base here is the same with the base of the logarithm. Okay, a to the power of log base a. So if you have the types like this, so this is just equivalent to x. Okay, we just take the radicand. And the fifth, note that if we have log base e, okay, this is a special logarithm, what we call an natural logarithm, or we can just simply call it ln n. Okay, this is ln, not in. Alright, so ln e is equals to 1. Right, so we look at example here. Okay, express the following expression in their equivalent logarithmic form. Right, so the question here, give the index form. We need to change to logarithm form. Alright, so we have 100 is equals to 10 to the power of 2. So in logarithm form, this is equivalent to log base 10, 100 equals to 2. And we know that if base 10, basically we didn't write the base here. So this is known as common logarithm. Okay, 5 cube is equals to 125. So in logarithm form, this is equals to log 5, log base 5, 125 equals to 3. Okay, a is equals to 1 over b. Okay, 1 over b is equivalent to b to the power of negative 1. So that's mean a is equals to b to the power of negative 1. So in logarithm form, this is equals to log base b. A is equals to negative 1. Okay, y equals to 5 to the power of x. So in logarithm form, this is log base 5, y equals to x. Alright, so you can practice by doing this question. This is the other way around, where in given the logarithm form, you need to change back to index form. So you can do the as exercise. Right, so we move forward. Okay, so tips. Okay, if 2 to the power of 3 equals to 8, so we know that the logarithm form is log base 2 8 equals to 3. Okay, 2 to the power of negative 3 is 1 over 8. So in logarithm form, that is log base 2, 1 over 8 equals to negative 3. But if we have the things like this, 2 to the power of x equals to negative 3. So for this expression, we cannot change to logarithm form because this is undefined. Because 2 to the power of x must be a positive number. So we, to the power n cannot be a negative number. So we conclude that for this equation has no solution, or the solution does not exist. Okay, so now we look at the rule of logarithm. Alright, so for a, m, and n, which is a real or positive real number, where a is not equals to 1 and b is in a real number, then so if we have log base a m times n, so we can separate those two radical here. It's become log base a m plus log base a n. Okay, so if multiplied, okay, we can separate to become a plus here. Okay, if we have the radical is divide, so for example here log base a m over n, that is equivalent to log base a m minus log base a n. So and you must be careful with the arrangement. So the first one is the numerator, which is m, minus log base the denominator, which is n. So don't do the mistake. All right, so c log base a to the log base a m to the power of b. So if the radicand have a power, okay, we can bring the power of the radicand to in front of log. So we can bring b in front of log, so it's become b log base a m. Right, so we can use this rule to help us to simplify the logarithm expression. Alright, so be careful. This is the most common mistake that students do. Okay, log base a m plus n is not equivalent to log base a m plus log base a n. So don't do this. Okay, it doesn't exist like this. Okay, the second mistake that student always do is log a, okay, base m over log a base n is not equals to log a log base a m minus log base a n. Okay, this is some mistake that student might do, so be careful, don't do this. And then right, so this is the third thing that you must be careful. If the whole logarithm is raised to the power of p, you cannot bring the p to the front of the log. Okay, so you must know the difference between the law of logarithm and what is not in the law of logarithm. Alright, so as a practice using the rule of logarithm, okay, the first one we have half log 16 plus half plus log 25. So log, that's mean that is base 10. Okay, so first we can change 16 in the base 2, so 2 to the power of 4, 16 is 2 to the power of 4, and 25 is 5 squared. And we can use this rule. Okay, if the radicand have the power, we can bring the power to the front of the logarithm. So we can bring 4 to the front of log 2 and power 2 to the front of log 5. And then we can simplify. Half times 4 is 2, so it becomes 2 log 2 plus 2 log 5. Okay, so we can factorize 2. It becomes 2 times log 2 plus log 5. Alright, so now we can use this rule. Okay, if we have log m plus log n, that is equivalent to log m times n. So we can combine those two logarithms. It's become log 2 times 5. And 2 times 5 is 10, so 2 log 10. Okay, log 10. Here we have base 10. Okay, with the same radical 10, so that is equivalent to 1. Okay, so 2 times 1, and this is equals to 2. Okay, sample second example. Okay, ln 30 minus ln 2 minus ln 3. Right, so for this question, you can do simultaneously all together, or you can do part by part. Okay, so for this, so we do step by step. Alright, so we just combine for the first and second term only. So we can use this rule. Okay, ln A minus ln B is equals to ln A over B. So it's become ln 30 over 2 minus ln 3. 30 over 2 is 15. So we get ln 15 minus ln 3. And then we can use again these rules. Okay, we can combine them. It's become ln 15 over 3. And 15 over 3 is equals to 5. So it's equals to ln 5. Okay, third example. Log base 10 81 over log base 10 9. Okay, so 81 is 3 to the power of 4, 9 is 3 squared, and we can use this rule. Okay, we can bring the power to the front of log, so we can bring 4 to the front, so it becomes 4 log base 10 3, and 2 log base 10 3, and then we can cancel out log base 10 3, so what's left is 4 over 2, and 4 over 2 is equals to 2. Alright, fourth example. Okay, log base 2, 32 over log base 2, 4. Okay, log base 32 is 2 to the power of 5, and 4 is 2 squared. Okay, we can bring the power to the front. It becomes 5 log 2 base 2, and 2 log 2 base 2, and then we can cancel out log 2 base 2, and then what's left is 5 over 2. Okay, the fifth example. Okay, 5 to the power of 2 log base 5 4. Okay, so for this question, we cannot just take the radical, because in front of log, it has a coefficient 2. So we need to bring this 2 to the power to become a power for the radical, which is it become 4. Okay, it's become 5 to the power of log base 5 4 to the power of 2. So 2 will become the power for 4. Right, so now we can use these rules. Okay, log a to the power of log base a. Okay, if the base is the same, so we have here 5. This is also base 5. So that is just equals to 4 squared. And 4 squared is 16. Alright. Okay, so we can change the base. Okay, if we have a logarithm expression here, let's say in base a, we can change the base from base a to the new base, which is base b. So we can use this formula. So log base am is equals to log base bm over log base ba. Alright, when using this formula, be careful, because for the numerator we take the radical, and for the denominator we take the base. Okay, now in all is in base b. Right, so this is the proof how we get the formula. Alright, so you can see along the construction. Okay, so as we can see, we get the same formula. Alright, so if m, okay, if the radical here is b, so we can substitute m equals to b, so we get log b base a is equals to log b base b over log a base b. Okay, so log b base b is 1, so that's equals to log 1 over log b over a. Alright, so for second formula here. Okay, that is for when we want to switch the base. Okay, as you can see here, the initial expression is log b base a. When we do the modification, it's become base b. So this is like we switch the base with the radicand. Okay, so we can use these two formula to change the base. Right, so for example, without using calculator, find the value of, okay, the first one is log 8, okay, base 0.5. Right, so for this question, it's much easier if we change all to base 2. Okay, now we in base 0.5. So we want to change the new base, which is base 2. We can use this formula. So this is equals to log 8 base 2 over log 0.5 base 2. Okay, 8 is 2 to the cube. Okay, and 0.5 is 1 over 2. Okay, 1 over 2 is also equivalent to 2 to the power of negative 1. And then we can use this rule. We can bring the power to the front. Okay, you can 3 log 2 base 2 and negative 1 log 2 base 2. And we can cancel out log 2 base 2. So it left with 3 over negative 1. That is equivalent to negative 3. Right, second example. Okay, log 0.25 base 8. Right, so we change to base 2. So it's become log 8 base 2 over log 0.25 base 2. Okay, 8 is 2 cube and 0.25 is 1 over 4. Okay, 1 over 4 is equivalent to 1 over 2 squared. Okay, and 1 over 2 squared is equivalent to 2 to the power of negative 1. So we can bring the power to the front using these rules. It's become 3 log 2 base 2 over negative 2 log 2 base 2. Okay, and then we can cancel out log 2 base 2. It left with 3 over negative 2. And this is equals to negative 3 over 2. Okay, example 3. Given that log 2 is 0.301 and log 7 is 0.8451. So evaluate, right, the first one is log 7 base 2. Alright, so here, what is given here is the common log, okay, which is in base 10. So we need to change, okay, this logarithm into base 10. Okay, so that is equivalent to log 7 over log 2, and we know the value for log 7 and log 2. We can substitute that value and then we just calculate that value. We get 2.8076. Alright, second example is, okay, log 28 base 2. Right, so also the same, we need to change first to base 10. So this is equivalent to log 28 over log 2. 28 is 7 times 4. So we can use this rule to separate those two logarithms. It's become log 7 plus log 4 over log 2. And log 4 is 2 squared. Okay, 2 squared, we can bring the power of 2 to the front. And then we can substitute the value for the log 2 and log 7. Okay, and then we just calculate this value. We get 4.8076.